Hey folks, how you guys are doing? I hope you guys are doing well. So today in this video we are going to discuss about caching, and before getting to caching we have to understand why do we need caching. Okay, so let's begin the video. In this video we are going to cover why do we need the caching, right? And what exactly caching is. And then we are going to discuss about the read through cache and then cache aside. These are different kinds, and then write through cache and write around. Then we are going to discuss about write back. After that we are going to jump on denormalization and then finally the summary. Before understanding caching, let's try to understand why do we exactly need caching. So the concept is vertical partitioning. What is vertical partitioning? So imagine we have a user table. This is a user table here, and it stores some information, like it stores the profile data. Here you have user ID, username and email. This is the profile data, and then you have last login, right? This is login history, and then you have billing address and payment method. So this is the billing information. Traversing this entire table is bulkier, and it is time taking, right? And it is more complex even. Like first you go here, then you are traversing the entire table. So if the length of the table is big, then you will be spending lot time. So what we do is we split this table vertically. What we do is, like, we split here and we split from this place. Also what we do is we split it here. So we split in three individual tables, which is like user profile, you separate the user login, and you separate the user billing. The problem was, as this table was growing, right, the query was becoming slower. There was slower query. We were scanning so many columns, and to optimize this, to convert into few specific field, we have splitted this user table. And this is also known as vertical partitioning. This is also known as vertical partitioning. I hope you got my point. Now we have the separate tables, like user profile, you have user login, and you have user billing. So what we are doing is we are reducing the disk IO. We are reducing the disk IO here. Okay, and also we are improving the query performance, and since each request only scans a relevant column, so we do not need to traverse the entire table. Okay, we are just traveling chunks. We are just traveling the chunks, or we can say smaller parts. This is how we are improving the performance. And what if we could store the frequently accessed data in memory for lightning fast access? This is where caching comes in. So we need caching here for storing the frequently accessed data. Now let's try to understand what exactly caching is. Let's try to briefly understand it. So caching is used to optimize the performance of a system by storing the frequently accessed data in memory. So instead of repeatedly fetching it from the database, instead of repeatedly going and traversing to the database, what you are doing is you are just storing in the cache memory. For the first time you are storing in the cache memory, and when you are again going to the cache memory for the second time, you are just checking whether it is present in the cache memory or not. And if it is not present, then you are again going to the database. So this is how you are optimizing it. So one of the most common caching strategy is cache aside pattern. This is an example of cache aside pattern. So let's try to understand this architecture, how it works. You have a client. So client is first sending the request and it goes to the application, right? First, the application is going to check the cache memory, whether the data is present in the cache memory or not. If it is not present, then it is going to request to the database. Okay. But if the data is already present in the cache memory, it is saying that there is a hit, means the data is present. So it is going to fetch from there and provide to the client. But if it is not present, it will go to the database, and then there is a cache miss. So it is going to read from the database, and then it is going to store into cache memory. Now let's discuss more about what exactly caching is. So caching is a powerful technique which is used to reduce the latency, and it is used to improve the system performance. So you are reducing the delay, right? Not each and every time you are going to the database, you are just reading from the cache. You are just reading from the cache. So you are actually reducing the delay, hence you are reducing the latency as well, and you are improving the system performance by improving the speed. So you are actually increasing the speed. Now there are several caching strategies that we use, like depending upon what the system requirements are, whether the focus is on optimizing the read heavy or whether it is a write heavy operation. So based on that we use like if you need data consistency, so based on these requirements we select those strategies. Let's try to understand the first caching strategy, which is read through. So in the read through strategy, the cache act as an intermediary. It is acting as an intermediary between the application, this is the application, and this is the database. So cache is acting as an intermediary. Okay. And when the application requests the data, it first look into the cache. So when the application is requesting for data, it is looking into the cache, right? So now if there is a hit, the application is going to read from the cache itself. But if there is a miss, then cache memory is going to request the database that there is a miss, you give me the data. And then from database, it is going to read the data, right? And then it is going to store for the second time. Then again, if there is any user, so user is going to request, now the data is already present in the cache memory. So there is a hit, right? You can read from the cache memory. This approach simplifies the application logic because the application does not need to handle the logic for fetching and updating the cache. Okay. The cache itself handles both reading from the database and storing the requested data automatically. So this is minimizing unnecessary data in the cache and ensures that frequently accessed data is readily available. For cache hit, let's say there is a cache hit. Okay. What is happening is read through provides low latency, right? And low latency for what? Low latency for data access. Whereas if there is cache miss, let's say there is a cache miss, so there is a potential delay. If there is a cache miss, you are going to the database, not the cache memory. So there is going to be a delay. This can result in high latency. It is resulting in higher latency. Due to higher latency, to prevent this cache from serving stale data, right? There is a time to live. This is very important. TTL refers to time to live. Time to live. What is time to live? Time to live can be added to the cache entries, like it automatically expires when the data after a specified duration expires. So it also expires, and allowing to be reloaded from the database when required. So whenever you need, the time to live get a refresh, and when the time gets expired, the time to live expire and the process expire. Let's talk about one more important point about read through caching. Read through caching is very important or very suited for read heavy applications. It is very optimal for the read heavy applications. Why it is good for read heavy applications? Because the data is accessed frequently but updated less often. So such as you have CDN, content delivery network, right? So you have social media, you are frequently reading, right? That's why it is best suited for the read heavy applications. Now let's talk about the second cache strategy, which is cache aside. Cache aside is also known as lazy loading. Let's try to understand by the architecture why do we call it as lazy loading. It is a strategy where the application code handles the interaction between the cache and the database. So the data is loaded into the cache only whenever it is required. So suppose there is an application, here we have the application and here we have the database, right? So what is happening is the same procedure is happening, like we are checking for data, whether it is available in the cache memory or not. If it is available, there is a hit, and if it is not available, there is a miss. Suppose there is a hit, then we are going to read the data from the cache memory itself. But if there is a miss, then first we are going to request to the database and the data is going to be fetched, and then it is going to store to the cache memory, and then again we are going to repeat the same process. So the application first check the cache for the data, and if the data exists in the cache, there is a cache hit that we have seen, and it is returned to the application itself. But if the data isn't found in the cache, if there is a miss, okay, the application retrieves it from the database, or we can say the primary data store. Then it loads to the cache for subsequent request. It gets loaded for the second time. The cache act as a sidecar. Why do we call it as a sidecar? It is acting as a sidecar. Let's try to understand this more well. So we are calling this as a sidecar. Why? Because to the database, and the responsibility of the application to manage when and how the data to be written to the cache. We are also managing like when do we need to cache it, when do we need to cache, right? We are defining certain algorithms like whether it is frequently used or whether it is not frequently used, what is the priority to cache the data. So we are deciding that. So when do we need to cache it, and how we are caching the how caching, right? We are defining certain rules as well. To avoid stale data, again we are using time to live. Here we are also using the time to live, and once the time to live expires, data is automatically removed from the cache as well. So why do we use cache aside? Cache aside is very perfect for the system where there is read to write. There is read to write, and this ratio is high, like read write. This ratio is high, right? Then we use like there are more read and there are less write. So because of this, we use cache aside. Like let's take an example. Certain examples you have first, like you are counting the prices, right? And then you have the description, you have the stock results, right? Stock results. So for all these things, you are using the cache aside. Like it is often read much more frequently because it is updated more fast. So the read is more frequent here. Read is more frequent here than it is updated. That's why we are using cache aside. Now let's talk about the write through cache as well. Let's discuss the another strategy of the cache. In the write through strategy, every write operation is executed on both the cache and the database same time. So what you are doing is like application is requesting and you are going to the cache if the data is present, right? So what you are doing is while you are requesting here, the request is going from the application to the cache, you are writing it to here at the same time. At the same time you are requesting, you are also writing the data here only, and then you are also writing that it is present here in the database as well. You do not need to render again and again. You do not need to. This is a synchronous process, mean the both the cache and the database are updated as a part of same operation, ensuring that there is no delay in the data propagation. So this approach ensures that the cache and the database remains synchronized. These both should remain synchronized. The read request from the cache will always return the latest data. So this also avoids the risk of serving stale data, right? Now let's talk about some advantages of write through. What are the advantages? The first advantage is data consistency. The second advantage is since the cache always contains the latest data, so read operations. Read operations benefit from low latency. These are causing low latency. That is a benefit. So the delay is reduced. However, write latency can be higher due to overhead. This is a disadvantage. Like due to overhead, there is a situation of overhead because what we are doing is we are synchronously making changes to both the cache and DB as well. At the same time, we are making the changes to the DB and cache both. due to which there is a overhead. So it is causing us a little problem. There is a write latency, but read operation have low latency. Now let's try to understand the new caching strategy, which is write around. Before this, we have discussed about write through. Now this is write around. Remember, this is write around. Okay, don't confuse by the words. Write around is a caching strategy where the data is written directly to the database bypassing the cache. What we are doing is, like, suppose here at application we are currently, and when we are requesting, right? So we are writing to database. At the first time only we are writing to the database. Okay. So in the second time we are going to the cache. If there is a cache hit, we are accessing from the cache, and if there is a miss, we are going to read from the database, because at the first time we have written to the database. Then we are going to update the cache. So what is happening here is, in the first time you write to the DB, you write to the primary database, and second, what you do is you are going to read from the cache. Read from the cache. And then in the third step, what you are doing is you are reading from the database. If there is a miss, you read from the database if there is a miss. And in the fourth, what you are doing is you are just updating the cache. You are updating the cache. So this is how the write around works. The cache is only updated when the data is requested later during a read operation, at which the cache aside strategy is used to load the data into the cache. So this approach ensures that frequently accessed data, you are only using the frequently accessed data. And what you are ensuring is it keeps the cache clean by avoiding the unnecessary data, and it might not be requested after being written. So writes are relatively faster here. Because at the first time you are writing to the database, and because they only target the database, so it do not incur the overhead of writing to the cache, because we are not writing at the same time to the cache and DB. We are first writing to the DB and then we are fetching from the cache memory. Time to live can be used here also. We are using the time to live to ensure that data does not remain in the cache indefinitely. So data should not be in the cache for longer period of time, right? Once the time to live expires, once this expires, what happens? The data is also removed. So data also removed. What is the advantage of write around? Write around caching is best suited for write heavy system. It is best suited for write heavy system. And it is also very much advantageous for not immediately, like those commands which are not frequent, and not frequently used, these doesn't get stored into the cache. That is one of the advantage. Now let's talk about another caching strategy, which is write back. So what we do in the write back strategy, the data is first written to the cache. Okay, and then asynchronously written to the database at the later time. Asynchronously means, like, first it is written to the cache, and then after certain period of time, once this is done, the data is asynchronously written to the database. Okay, the database is updated after a period of time, like we are refreshing it. Okay, this strategy focuses on minimizing the write latency. So we are actually reducing the write latency. We are actually reducing it. So this deferred writing means that the cache acts as the primary storage. Here the cache is acting as the primary storage, and during write operation, while the database is updated periodically in the data, because we are updating the database periodically. So at the time when we are writing to the cache, Cache is also the primary, right? Because we are not getting from the database. We are writing periodically to the database. So what we are doing is we are writing periodically to the DB. Now let's move to the next topic, which is denormalization. So you have used most of the relational databases. You have used most of the relational databases. Relational databases. These use normalization. So what you are doing here is you are actually breaking the tables. You are just partitioning or breaking the tables. Suppose this is a ABC table, right? So you are breaking into A attribute, you are breaking into B and C attribute. These are three different tables. You have broken down the one into three smaller tables. This is how normalization works. For example, there is an e-commerce system, right? You have an e-commerce system. And in the e-commerce system, you have three different tables. You have user table, and you also have orders table. And let's say you have a products table. So the user table is storing the user detail, and the orders table is storing the orders of user, and the products table is storing the product detail, right? While this reduces redundancy, this is reducing redundancy, like we have discussed about normalization, it reduces redundancy. So it also reduces the redundancy. It also introduces joins. It is also introducing joins. When retrieving the data from multiple tables, so when you are retrieving the data, you are going to user table, and then you are going to check orders table, and then you are going to check products table. These are interlinked, these are connected to each other. User table, suppose you are going to orders table, so you are going to check for the user, which user has made the order, right? And which order is connected to the product. Then these are interconnected by joins, right? This is also slowing down the query. It slow down the query. We know that normalization is reducing the redundancy. I know that, but it is also introducing joins, due to which it is slowing down the retrieval time. Let's try to understand this using this example query. So select order ID, right? And you are selecting the username, you are selecting the user email, you are selecting the product, and you are selecting the amount of the product from the orders. So we actually have some joins. Here we have a join like user ID in the order and user ID in the user table. So we have user ID in the user table, and we have the user ID in the orders table. With these, we are performing some join operation, and with the help of join operation, we are driving a user order table, like which user has made which order. There is user 1 with order 101, and these are and so on users, and we are performing a join operation. So why do we use denormalization? Denormalization reduces the number of joins by combining the related data into a single table. So even if it means some data gets duplicated, even if it means like some data is getting duplicated, but we are actually reducing the access time. So here what we are doing is we are reducing the access time, even if the data is getting duplicated. So instead of using separate tables, you are not using the separate tables here. You are doing the denormalization. You are using single table. I know there is redundancy, but you are also reducing the delay. You are also reducing the delay, and you are also increasing the fetch time, fetch speed. I hope you guys have understood all the concepts. So this was all about this video. Thank you for watching. Do like, share and subscribe my YouTube channel Code Money, and do mention in the comment section which part you don't understand, and try to ask question in the comment section. We'll see you in the next video. Till then, take care. Bye.